I have already built a tracking power supply. This would only track from a couple of volts to 12 volts. I developed a new schematic that I think will allow it to track to whatever voltage is supplied. Now there are some limitations there. The device is caused to track by a dual operational amplifier. I'm only using half of that dual amplifier. It has a maximum differential voltage of 40 volts. I'm supplying 5 volts to the positive power terminal of this op-amp. The other side of the op-amp I'm connecting to here, which is the output of the full wave rectifier. Keep in mind this is not a bridge rectifier. So with 5 volts here, we can have no more than 35 volts here. And hopefully that would be when the whole power supply is at no load. Some transformers vary wildly if they're not used at full current. So no load voltage here. And since it's an identical, hopefully it's an identical transformer, it'd be 35 volts here. No load, in order to minimize overvoltage on the operational amplifier. The starting point for this power supply is this board. Now this board was not sold as a tracking power supply board. It was sold for building a completely symmetrical plus-minus power supply. Apparently for audio use. It had an integrated circuit, 2 halves, of course. It was a dual integrated circuit. 1 half was exclusively devoted to the positive output, 1 half to negative output, and it was some sort of feedback system to minimize noise. I'm not using the board for that purpose. I am using this board because it costs $3.60, and most of the holes and component locations I intend to reuse. Schematic is color-coded. Everything is in black except for the transformer. Is on this board, and it's identified on this board as exactly what it is. Things in green are located on the board, but they weren't intended to be used on this board. Here in the layout, you can see these green. They actually show up as blue because I'm using genuine Epson ink cartridges, and the color rendition is for shit. And the remainder of the components that are shown in red are going to be mounted on a daughter board that's mounted above this board. Because I bought a couple of different Servo power supply boards. I actually bought some green ones, and I bought a blue one. I looked at the blue one and decided it was not suitable. So in the notation here, I call it a power supply board green. This is version 2. It gets complicated by the fact that I bought this board on eBay. There's at least one seller on eBay that sells this board. The board he delivers is green. The board he shows in his eBay seller's information is a blue board. I ordered a second allotment of boards just to make sure that they were still green and not blue. The only thing I can recommend is that you look at the component layout very carefully on this board. Of course, there'll be no components on it, it's just a board. And if the other side of the board is shown in the advertisement, it looks like this. And you can see that it was designed to be a completely symmetrical power supply with nothing crossing over. In any event, this is the board I'm using. For the last 6 months, it's been sold on eBay by this guy. So I'll put all of the black components on this board, and you can see what's missing. Then I'll proceed to put the green components on it. So green in this video looks like this. Or at least green on this drawing looks like this. Here's the board with all of the components that are silk screened on. They're going to be used in this build. Now, when I say all the components, I'm not quite true. These, the 317 and the 337, have not been installed, nor has a socket been installed. So really, there's very few components there. I believe this to be electrically, it's a little bit physically different, but electrically the same. You can see there's a whole bunch of stuff there. This whole group of components here, and from this red capacitor to this red, all of that stuff's not here. These electrolytics are not used. Now there are two potentiometers here. In this build, one potentiometer will be replaced by a jumper. I'll get to that. And the second potentiometer, I've made provisions to remote mount it. So there's a 3-pin, 2.5 millimeter pitch JST connector installed. And for this connector, I had to enlarge slightly the 3 holes that were originally designed to be occupied by a board-mounted potentiometer. I have used 1 amp diodes. If you use 3 amp diodes, and I was for a while, these mounting holes need to be enlarged also. The components shown here are the ones in black. Except for the potentiometer. That's connected to the board, but via a connector. Now the dip socket needs to be modified. If you look at the schematic, you'll see there's no little circles on pin 1, 2, 4, and 8. Here is the socket with pin 1 removed. That is the connections for pin 1. And these are easily removed from these sockets. Got a dental pick here. And what I do is get down in here, grab a hold of it, and pull it out. So there's pin 2. One, two, 4, and 8, which is that one. Now once this is prepped, it can be installed on the board. Here's the board with all of the components indicated on the silk screen installed. At least that's all the components I intend to use. I should note these 2 capacitors, which would be installed normally standing up, are bent over. They're lying down. We'll get to that. And the next thing I'll do is put the forced components on. That's components are going to reside on the board, but don't have any silk screen to indicate where they are. So I've installed the forced components. Now they're the things indicated in green. May show up blue on your screen. They consist of 4 diodes and 2 jumpers. One of the diodes is here. It uses 2 existing holes, but it's not on the silk screen. The jumper uses 2 existing holes, and of course it's not on the silk screen. These 2 diodes are here and here. And they use existing holes because the silk screen for this capacitor has 4 holes in it, 2 here and 2 up here. I guess so you can use different physically sized capacitors. Ironically, these little red fellows are the same as a marked capacity. So far, all of the forced devices have used existing holes. I've got the thing upside down. Now remember, this is a top view. There is a 4th hole here, but it's obscured by the JST connector, and that's here. And then it goes down to this junction, which is down here. There's no hole available down here. In fact, I have to make a correction in the drawing. There is no hole. This merely goes down and lies between these two. And it does need insulated. It passes over some traces that are probably not used, but I prefer not to touch them. J1 does not need insulated. I put the yellow insulation on just to make it stand out. So, with the exception of the 317 and the 337, this is complete.